Hello everyone. In this video, first we will have a look on generalized Elgamal cryptosystem. However, we have already checked about this generalized Elgamal cryptosystem. It is a public key cryptosystem, but just to take a review about generalized Elgamal cryptosystem, and then we will check that how this Elgamal cryptosystem can be implemented over elliptic curves. So let's just to take a review about generalized Elgamal cryptosystem. This can be over any group. Let's say G is a group, G star is an abelian group, so this can be over any group. So this G star is an abelian group. So we need to find now we need to, for Elgamal cryptosystem, we need to define discrete log problem for G star. So if you remember that Elgamal cryptosystem is based on discrete log problem. So for this G star to be an abelian group, and we need to for defining Elgamal public key cryptosystem on this G star, first we need to define the discrete log problem on G star. So what is given? Given is a group G. So the group G is given. It is a finite group. It is a finite group, and then alpha and beta are two numbers, where alpha belongs to this group G and beta belongs to H. So now what is H? H is a subgroup of G generated by alpha. H is a subgroup of G. So H is a subgroup of G which is generated by alpha. So when we say that it is generated by alpha, it means alpha is a generator of this group, or you can say that alpha is a primitive element of this group. So it means H is equal to alpha to the power I for all I greater than equal to 0. So this is given is G, alpha and beta. G is a finite group, alpha is an element of the group G, and beta is element of subgroup H. And how this subgroup H is formed? It is alpha to the power I, where I is greater than equal to 0. So alpha is the primitive element, or you can say that alpha is the generator of H. So if alpha is the generator of H, then alpha is the generator of G also. So now let's say if we write alpha to the power A, it means we are multiplying alpha with alpha up to A times. So this is alpha into alpha into alpha up to A times. So now if alpha to the power A is given, then to find the value of A is a discrete log problem. If this is given, then finding the value of A is a discrete log problem. So this is defined as discrete log problem for group G star, and for simplicity we will consider a cyclic group. Means we will consider multiplication as operation, and we will consider a cyclic group. So now let's say this G star is a cyclic group. This G star is a cyclic group, and alpha is the primitive element of G star. Alpha is primitive element of G star. Alpha is primitive element of G star. Then select an A such that A lies between 0 and number of element in the group minus 2. So this beta is going to be alpha to the power A, where alpha to the power A is defined as alpha into alpha into alpha A times. So this is how we define discrete log problem. To find the value of this A is discrete log problem, because it is a hard one. To finding the value of A is hard. So this is discrete log problem. Now what is Elgamal cryptosystem? Generalized Elgamal cryptosystem. So let's say we have a sender. Let's say we have Alice. We have a receiver, Bob. Bob is having its own public key and private key. This EB is the public key of Bob, and this db is the private key of Bob. Now Bob will generate the setup and then send its public key to Alice. So what setup Bob is going to run? First it is going to select a group G star. This we have already done, Elgamal Cryptosystem. This is just to take a review, because after checking this we are going to describe that how Elgamal Cryptosystem over elliptic curve is defined. So now it will select alpha is a generator of G star. Alpha is this is done at Bob's end. Alpha is a generator of G star. Select an A. Bob will select an A. It is going to be secret for Bob. It is going to be secret or public private key for Bob, and this A should lie between 0 to G minus 2. Now beta is equal to alpha to the power A will be calculated, and this beta is the public key of Bob. So the key set K is equal to G, alpha, A and beta. So this key space is equal to G, alpha, A and beta, and out of this key space this A is only the secret. This A is the secret key or private key. Rest all G, alpha and beta all are public. What is the plain text? Plain text is every element of group, and ciphertext is G into G, because in Elgamal Cryptosystem we know that it generates two ciphertext in a group. So first one will be the y1, which is equal to alpha to the power k. So it will be alpha into alpha k times. And second one is y2, which is equal to, we mask it, this is masking x into beta to the power k. So this is encryption. So encryption will be done. First Bob will send its private key. So now Alice is having Bob's private key, which is Bob's public key, which is G, alpha and beta. Now Alice will do the encryption, and for this purpose of encryption Alice will select a random number k. So now encryption will be done with public key of Bob. Let's say x is the message and k is the random number which is selected by Alice. So now it will gives us y1 and y2. Then Bob can decrypt it. Bob can decrypt it at its own end. So this is the basic definition of Elgamal Cryptosystem, which we have already done in previous weeks. So now we are going to define that how this Elgamal Cryptosystem is defined over elliptic curve points. Elgamal Cryptosystem defined over elliptic curve points. Defined over elliptic curve points. So the elliptic curve, here we are going to take a mod p under mod prime. So E is xy, where xy belongs to zp into zp, and it is defined as y square is congruent to x cube plus ax plus b mod p, where a comma b belongs to zp and 4a cube plus 27b square is not congruent to 0, union point at infinity. And now we see that this elliptic curve under the operation plus is a group. This we have already proved in previous videos, that this elliptic curve E under the operation plus is a group. So now for this group we are going to define our Elgamal Cryptosystem. So let's say this has 2 points P and Q. P is equal to x1 y1 and Q is equal to x2 y2. So if we define the elliptic curve, there can be 3 cases. First one is if Q is equal to minus P. In this case, P plus Q is equal to P plus minus P, which is going to be point at infinity theta. The second one says when q is not equal to p. So in this case p plus q is going to be r, which is equal to x3 and y3. And how we are going to define x3 and y3? This we have already given. x3 is equal to lambda square minus x1 minus x2 mod p, and y3 is equal to lambda x1 minus x3 minus y1. All operations are under mod p. So this is how we define x3 and y3. Now here lambda we can define in two cases, when it is a tangent and when it is not a tangent. So it means when p is equal to p is equal to q, and when p is not equal to q. So where lambda is equal to, so in first case lambda will be y2 minus y1 upon x2 minus x1. So here because we are taking mod operation, so it will be x2 minus x1 inverse mod p if p is not equal to q. And otherwise lambda will be 3x1 square plus a 2y1 inverse mod p when p is equal to q. So this we know that this E plus is a group. E plus is a group, and we have defined the group, we have defined it for define the curve in the previous video, and curve is y square is equal to x cube plus x plus 6 over z11. So here a is equal to 1 and b is equal to 6. So for this curve we already defined the points on this curve. So let me write the point only, because we have already find out the points in previous video. So the points are 2, 4, 2, 7, 3, 5, 3, 6, then 5, 2, then 5, 9, then 7, 2, then 7, 9, then 8, 3, 8, 8, 10, 2, and 10, 9, and along with this point at infinity theta. So these are the point on the curve E, where the curve is y square is equal to x cube plus x plus 6 over z11. So these points we have already find out in the previous video. So now we need to choose a primitive element. Now let's say these are the element of group. So among these element we need to choose the primitive element. So primitive element or the generator. So let's say alpha is equal to 2, 7. We choose an element alpha is equal to 2, 7, and we want to check if it is a primitive element or not. So if it is a primitive element, so what we do, we when G star was a group, so we do alpha to the power alpha to the power alpha 1, alpha to the power 2, alpha to the power 3. Now E plus is a group. So here how we find? We will find 2 alpha, 3 alpha. So 2 alpha will be alpha plus alpha. So it is going to be 2, 7 plus 2, 7, because here we are considering addition as an operation. So here if you see the case, here P is equal to Q. So if P is equal to Q, what is the value of lambda? The value of lambda is this one, 3x1 square plus a 2y1 inverse. So we just say this is x1 y1, this is x2 y2. So this lambda will be 3x1 square plus a into 2y1 inverse, 2y1 inverse mod 11. So the value of a is 1, and we will put the value of x1 and y1. So 3 into 4, x1 is 2 plus 1, 2 into 7 inverse mod 11. So here it will be 12 plus 1, 13, and it will be 14 inverse mod 11. So we can write for this it is 13 and it is 14 inverse, it means 3 inverse mod 11. So that 3 inverse mod 11 is going to be, what will be the value for 3 inverse mod 11? So it is going to be 8, and this 13 is going to be 2. So 2 inverse, so now the lambda comes out to be 8 here. For this, lambda comes out to be 8. So because it is 8 inverse, and 8 inverse is equal to 3, and lambda comes out to be 8. So when lambda is 8, so lambda comes out to be 8, and we will calculate x3 and y3. x3 is equal to lambda square minus x1 minus x2 mod p, or we can write mod 11. So it will be lambda is equal to 8, 64, x1 and x2 are 2, so minus 2 mod 11, and it comes out to be 60 mod 11, which is 5. Similarly, y3 is equal to lambda x1 minus x3 minus y1. So it will be 8, 2 minus 5 minus 7 and whole mod 11. All the operations are mod 11. Mod p, so p here is 11. So it is minus 24 minus 7, which comes out to be minus 31, and it comes out to be 2 mod 11. So y3 is equal to 2. When we solve this, y3 comes out to be 2. So the point is 5, 3, and this 5, 3 belongs to E. We see here where we write all the points. This 5, 3 belongs to E. So this is one point. Sorry, the point is 5, 2, and this 5, 2 belongs to. So now similarly, now we find 2 alpha. Similarly, we can find out 3 alpha. So this 3 alpha is equal to, so this 3 alpha will be 2 alpha plus alpha. So 2 alpha is here 5, 2, and alpha is q, so alpha is 2, 7. So now this is x1 y1, and this is x2 y2. So here is the case when p and q are not equal. So here lambda is going to be y2 minus y1 into x2 minus x1 inverse mod 11. So when we will put the value, it comes out to be 5, it comes out to be minus 3 inverse mod 11. So now it comes out to be 5, and it comes out to be 8 inverse mod 11, and 8 inverse is equal to 7. So it comes out to be 5 into 7 mod 11, which is 35 mod 11, and it comes out to be 2. So lambda is 2. So when lambda is 2, x3 is equal to lambda square x1 minus x2, lambda square minus x1 minus x2, and this is mod 11, and it comes out to be 4 minus 5 minus 2 mod 11. So it comes out to be 4 minus 7 mod 11, and it is minus 3 mod 11, which comes out to be 8. So this is x3. Similarly, we can calculate y3. So y3 is equal to lambda x1 minus x3 minus y1 whole mod 11. So it is 2, 5 minus 8 minus 2 mod 11. So it is 3. So the next point is 8, 3. 3 alpha is 8, 3. So 8, 3 also belongs to the group here. So similarly we can find out 4 alpha, 5 alpha, 6 alpha and up to 11 alpha, 12 alpha, and we will check all the points are here or not. So when we will calculate like 4 alpha, it comes out to be 10,2. When we calculate 5 alpha, it comes out to be 3,6. When we calculate 6 alpha, it comes out to be 7,9. 8 alpha comes out to be 3,5. So all elements belongs to the group. So hence we can say that 27 alpha 27 is a generator of E plus under the given curve x y square is equal to x cube plus x plus 6. So 9 alpha is equal to 10,9, 10 alpha is equal to 8,8, 11 alpha is equal to 5,9, 12 alpha is equal to 2,4. So this is how we generate this group. Now how this Alice and Bob communicate? So let's say this is Alice and this is Bob, and we are considering the same curve x cube plus x plus 6. So alpha is equal to 2,7. Now let's say a is equal to 7, and this is the secret key of Bob. Beta is equal to a to the power alpha. So here we are considering addition, so beta is equal to 7 alpha. So 7 alpha is equal to, what is the value of 7 alpha? 7 alpha is equal to 7,2. So here I forgot to write it. 7 alpha, it comes out to be 7,2. So now this 7 alpha is public. Now this 7 alpha is public because the public key is alpha, beta and E. So now Alice is select a K, and then it is going to encrypt y1 is equal to K to 2,7 and y2 with masking is equal to K x plus K 7,2. So this is called encryption. Similarly decryption can be done by Bob, y2 minus 7 y1. So y2 minus beta to the power K. So now let's take an example, the numerical example for elliptic curve, Elgamal Cryptosystem over elliptic curve. Let's say the message x is equal to 10,9. So this is the message which Alice want to send, or you can say this is the plain text. Fine. Now the K selected by Alice is 3. Alice is going to select this K. This is an example. Now y1 is going to be alpha to the power K. So we can say that y1 is going to be K alpha because operation is addition. So it is going to be 3, 2,7. So which is going to be 3 alpha, and the value of 3 alpha is, value of 3 alpha we just find the value of 3 alpha is 8,3. So it comes out to be 8,3. Now y2 is masking x plus K 7,2. So x is 10,9 and K is 3 7,2. So when we calculate 3 7,2, it comes out to be 3,5. You can calculate it now, and 10,9. When we add these 2 points, it results as 10,2. So now we have two messages, y1 and y2. What Bob is going to do as decryption, y2 minus ky1. So it is going to be y2 minus ay1. So it is going to be y2 10 minus 2, 10,2 minus 7 and 8,3. So this is going to be 3,5, 3, minus 5, which comes out to be plus 3,6, and here 10,2. So 10,2 plus 3,6 is equal to 10,9. So here we get the same x. So it is verified. So here we calculate like 3 7 comma 2, we calculate the same method. This is let's say this is a point P, so this is 3P. So 3P we can calculate 2P plus P. So first for need to calculate 2P, we need to calculate P plus P. And this is, let's say this is P and this is Q, both are unequal. We will calculate lambda, we will calculate the point, and it comes out to be 10 comma 2. So this is how Elgamal cryptosystem can be defined over elliptic curves. Okay, so let's just take a quick revision. This is just a definition of Elgamal cryptosystem. So we define, like for if we are defining Elgamal cryptosystem for group, we define the discrete log problem to select the value of A, where alpha is the generator and beta is equal to alpha to the power A. So to find the value of A, and this A is the secret key of Bob. So to find the value of A is a discrete log problem. We can say this is a hard problem. Okay, so now we define that how this is just an overview of Elgamal cryptosystem, how this cryptosystem work, and then we define Elgamal cryptosystem over elliptic curves. So here we take the example of same curve which we derived in the previous video. We select an element alpha, let's say alpha is equal to 2 comma 7, and then we generate all the other element with the help of alpha. So if we say that alpha is a primitive element, then alpha to the power 1, alpha to the power 2 under operation multiplication. Here we are choosing the group E plus, so it means alpha plus alpha, alpha plus 2 alpha. So we find all the values 3 alpha, 4 alpha, and I show you the method how we can find these values. And then we just take an example that how this Elgamal cryptosystem works. So this is about the elliptic curve cryptography. Thank you.